Rahim. Assalamu alaikum students. Our subject is new informatics with the code of GS250. Topic for this week is global positioning system. We have already covered first part of this topic and it is a continuation of the global positioning system for week 4, and this is our lecture 4. Coming towards outlines of this topic, that what is GPS, segments of GPS, space segments of GPS, control segment and user segment. We have already read this topics in the previous week. Today we will cover how the system works, triangulation or trilateration, distance measurement or distance measuring, accuracy and precision in GPS, source of error and uses of GPS. A little bit revise is necessary. That what is GPS? GPS is a global positioning system which is based on navigation satellites. So here are three segments of GPS. That is space segment, means space vehicles are known as space segments, and space segment, the vehicles, the satellites which moves or revolves around the Earth in the space is known as space segment. The control segment, which is on the Earth surface, which control the overall system of GPS, is known as control segment, and the user segment, which we use, like that is GPS device or a receiver. Today we will cover how the system works, that how the GPS works, that triangulation or trilateration method. We call it trilateration method because triangulation works on angles, while trilateration is not working on angle. So we will cover trilateration methods, distance measuring, accuracy and precision in GPS, and sources of error in GPS and uses of GPS. That we use a GPS receiver or device. So coming to the topic, that is how the system works. The system works, it needs 4 satellites. Minimum 4 satellites are required for a receiver, that position can be measured or location can be seen on the surface of the Earth or above the surface of the Earth. There are 24 plus satellites for a GPS. There are monitor stations also, that is Diego Garcia, Ascension Islands, Kwajalein, Hawaii, Colorado Springs. The current FMS is transmitted to the users. So what is FMS? We will see it, that what is FMS. FMS is the change or a little bit difference or movement of a satellite from the original path is known as FMS. GPS control, Colorado Springs and end user, which we use as a GPS receiver. So how the system works? It's a trilateration. In the trilateration, there are minimum 4 satellites required for a system. For example, here is given satellite 1, there is satellite 2, and this is satellite 3, and there is also one satellite which is called a satellite 4. We will draw here a satellite 4 to cover the position of a point. This is a 4th satellite. We will use, as we have drawn here. This, for example, this one is 4 satellites. This one is for X, this one is for Y, and this one is for Z, and this 4th one is for T, delta T or time. So all the 4 satellites are necessary to point the position of a GPS on the surface of the Earth. This system or this method is known as trilateration. In the trilateration method, 4 minimum satellites are required. This is a trilateration, and it is difference from triangulation in the form of that it has no angle consideration, while triangulation considers angles. So therefore you should know that trilateration is a little bit change from triangulation. Distance measuring is also covered in this GPS system, that the whole system was around the time. Distance is equal to rate multiplied by time. That is, S is equal to V T. It shows that if you want to cover or to measure a distance, so this formula may be used to find out the distance of any position of any point. So AB is the speed and time is, as you know, time. So through this way we can find the distance. It is equal to VT. It might be the unit, may be kilometers and centimeters, etc. It may be changed or in miles. Time is time it takes signal to travel from the satellite vehicles to GPS receiver, and the time here explains that is, for example, this one is a satellite and this is a GPS receiver. So this can be the distance can be measured while using the above formula. So S is equal to VT, where V is the speed of light, which is C is equal to 3 into 10 to the power 8 meter per second. Each satellite carries around 4 atomic clocks. There are 4 atomic clocks in each satellite, that is rubidium and cesium. Uses the oscillation of cesium and rubidium atoms to measure time. Accuracy of these atomic clocks is plus minus a second over more than 30,000 years. So it's very accurate, and this accuracy is too much enough, and that is 30,000 years plus minus a second. What are the specificals and receiver clocks? So specifical clocks, they are cesium and rubidium clocks in the specificals, which are 2 in number. For example, these are 2 rubidium and 2 cesium clocks installed in space vehicles, that is in satellites. These are generally price of a satellite clocks. The second one is receiver clocks. Receiver clocks. This clock is similar to the quartz watches. Always an error between satellite and receiver clocks. There is an error occurs, so we will cover it in the few next slides. 4 satellites required to solve for X, Y, Z and time. What is accuracy and precision in GPS? The nearness of a measurement to the standard or true real value is known as accuracy, while the precision is the degree to which several measurements provide answers very close to each other. So there is a little bit of definition, you can see it by yourself. What affects accuracy and precision in GPS? We will see that what are the factors which affect accuracy and precision in GPS, which are known as errors in GPS. These are sources of errors, that is selective availability, geometric dilution of precision, clock error, ionosphere delays, and multipath error. Covering the topics one by one. That is, what is selective availability, geometric dilution of precision, clock error, and ionosphere delays, and the last one is multipath error. Selective availability is the intentional degradation of GPS accuracy. As US launched this system, they left the degradation in the signals. It means that it doesn't show the accurate position of a GPS receiver. Like for example, if someone position is this one, but due to selective availability, the intentional degradation may show you your position like here or like here or like here. So it doesn't show you a real position where you are standing, where you are lying, or whatever it is. For selective availability causes this degradation, and the selective availability 100 meter in horizontal and 160 meter in vertical displacement has been given. For example, this is an earth surface, and vertical movement or vertical degradation which was given to it was that is 160 degree meter. From the earth surface, it covers 160 meter in vertical and 100 meters in horizontal. For example, someone is standing here, so it will show you 100 meter from the point to the left or to the right, like here, or it might be here. And in the vertical position, it might be, for example, at 160. So it may be like an object is lying here. The real position of the object is this one, but it will show you the object's position 160 meters above the earth's surface. This is known as account for most error in standard GPS. This GPS error has been stopped in my 2000, and then it came towards this one. So after turn off the selective ability, it may be seeing that now it shows the accurate position of an object or of a point or of any location. The second error, that is known as geometric dilution of precision, occurs due to the movement or the position of the satellites. It describes the sensitivity of receivers to changing the geometric position of the satellite because the higher the dilution of precision value, the poorer the measurement. For example, these are two figures. This one has a poor geometric dilution of precision, and this one has a good geometric dilution of precision. If someone having a receiver here, so these are aligned too much near with each other, so it will not cover the original position of a receiver, and this will show the original position of a receiver. For example, it's like that. For example, this is satellite 1 and this is satellite 2 and this is satellite 3, meaning that these are much more near to each other, so these are causing dilution. So this is an error and cannot show the original position of a point. This shows that quality and dilution of precision. For example, if the dilution of precision value is 1 to 3, it will be good. The quality of a position will be okay, very good. If dilution of precision values comes toward 4 to 5, then it will be in good. And as the DOP value increases, the quality is decreases, meaning that both of them have an inverse relation. DOP has inverse relation with the quality of a position. Dilution of precision has inverse relation with quality. As the value increases, quality decreases. Clock error, how clock error occurs, the differences between satellite clock and receiver clock causes a clock error. Because this is a quartz clock and the satellite uses atomic clocks, that is cesium and rubidium. So this error may occur due to the quartz clock or the material used in this clock. And what is the ionospheric delays? Ionospheric delays mean that the ionosphere, the upper part of the earth, which consists of a lot of ions. Due to these ions, ions mean positive or negative charges, which may cause positive or negative charges, which may cause the signals to be degraded. Like, for example, if a signal coming from a satellite, it may be deviated from its original position due to the positive charges or the negative charges, which are known as ions. So therefore this portion of the atmosphere is known as ionosphere. So delay of GPS signal as they pass through the layer of charged ion and free electron known as the ionosphere. This one error is due to multipath. So multipath error is caused by local reflection of the GPS signal that mix with the desired signal. For example, this is a satellite and the signals bounces with this object, this home. After bouncing, this reflected towards the GPS. So the distance covered is changed. This is the real signals which are coming towards the GPS, and this may be deviated from the house or any obstacle. So this is also causing an error to the GPS, and it might degrade the accuracy and precision of a GPS receiver. To overcome the difficulties in a GPS, we use differential GPS. Differential GPS is used to receive an accurate position of an object. Method of removing error that affect GPS measurements at a base station receiver is set up on a location where the coordinates are known. Signal time or at reference location is compared to at remote location. The time difference represents error in satellite signal. A real-time corrections transmitted to remote receivers. Single frequency 125 meter, dual frequency sub-meters. Post-processing differential GPS involves correcting at a later time. In this system, differential GPS system, a base station is set up at a location, at a known location. For example, this is a base station, and these are the satellites, satellite 1, 2, 3, etc. For example, these are receiving the signals, which is base station. From this base station, further the receiver, which consists of a hover base and a receiver which receives the signals and shows an accurate without errors position of that particular point or location is shown by the differential GPS method. The wide area augmentation system is developed by federal I'm confused here. System of slides and ground station that provide GPS signal corrections. 25 ground reference stations across US. Master stations create GPS correction message, corrected differential message broadcast through stationary satellite receiver, 5 times accuracy, that is 95% of time, and on the request WAAS enabled GPS. What is wide area augmentation system? This system is developed for mainly for aircraft, vehicle, aircrafts and airplanes, etc. It's therefore to show the exact location of to the pilot. So therefore, the wide area augmentation system is developed. It is generally used in US with the 25 ground reference stations. This is also the wide area augmentation system is an air navigation developed by the Federal Aviation Administration to augment the global positioning system with the goal of improving its accuracy, integrity and availability. As I told you that it is used for accuracy and precision. So this is, you may see that wide area augmentation system. This is Earth ground stations, and this one is wide area master station, and there is a reference station established around to clear or to show the position of a plane or any object like that may consist of a GPS device that is in US especially for aircraft purposes. Global positioning systems are till date we have following global navigation satellite system launched by a different country, that is Navstar global positioning system, which is launched by United States, and the GLONASS by Russian. These are also an Indian satellite global positioning system, and there is also a European system which is Galileo positioning, and there is also a Chinese global positioning system which is Baidu navigation system, which will be launched in 2017. What are the applications and uses of a GPS? It is used in a lot of in a lot of areas, that is particular petroleum industry, electrical or power grids, space application, air traffic control, personal navigation, transit operations, shipment operations and emergency services, etc. This can be seen that its application in the petroleum industry, power grids, space application, air traffic control, personal navigation, transit operation, shipping operations, emergency services, and vehicle and tracking. Coming towards the petroleum industry, that how we can use a GPS in the petroleum industry. For example, if we want to see the oil or the petroleum well, for that purpose we use GPS points, and GPS points shows us a location where the well is located. To that GPS points we can track that position and that location, and we can easily go to the point and may use it for our purpose. The second application is in the power grids. Power grids is also it can also be can also utilize the GPS. Like if you want to install a power lines or cables along a road or in any area, so we use GPS and we can mark their position. For example, 1, this is 2, this is 3, this is 4, this is 5, etc. And these position, and to the help of this position, we can see the we can install the poles for or towers of the electric power grids. It can be used in the space application, as we have we see that different satellites that is launched. So in this members we can use it as a space application and air traffic control like aeroplane, etc. We can use GPS. Personal navigation, nowadays we use it for personal navigation. For example, if you want to go somewhere on the Earth's surface, so we may open the Google map and just give XY coordinates or name of the area. After giving the name, it directly shows us the point and the location, and also shows the distance and directions. In the transit operation, like the air traffic, it can also be used in the transit and the shipment operations and emergency services and vehicle and tracking. Like nowadays, every vehicle has this technology of GPS and GPS installed in the cars and the vehicles that can be traced and that can see their positions, that where the vehicles are going. So all of these are the applications of a GPS. Besides these applications, it can also be used in forestry, in geology, and civil engineering, construction, etc. It has a lot of applications nowadays as technology develops, and the system is coming towards technology. So GPS also plays an important role in different fields. I hope you have understood this lecture. Thank you. If you have any query, please email me.